Okay. So when you get into the photoelectric effect, there's only this is like the mother of all equations on the photoelectric effect. And this is what's on your equation sheet. And it's K max equals HF minus the minus the Greek letter phi.
The equation on that sheet.
Yeah, that's what's on your sheet. This is straight off of what's on your equation sheet.
Nice.
So let me kind of explain this in terms of code, okay? So the end of that Greek letter phi, that is the bond money. This is how much money it takes for me to get Cohen out of jail, okay? 500, 700, whatever that is. And each metal has a different work function. And that's based upon how tightly bound the electrons are to the nucleus. So that's your work function. That's how much money is set by the judge. The HF is the amount of energy from the photon that's coming in. So you have a photon part, which is your HF. Sometimes you can also see that written as HC over lambda. It's the same thing, okay? So what that tells me is how much money I bring to the story, okay? So if the work function is $500 and I only show up with $490, what's going to happen?
Nothing.
Absolutely nothing. And this is going to be important. If that HF, the energy of the photon, does at least not exactly equal the work function, nothing's going to happen. And that was counterintuitive to the classical idea where, okay, hey, maybe we don't see it initially, but if we shine that light long enough, hey, eventually some of the electrons are going to jostle around more, and it's going to like boil, and they're going to begin to boil off, and then eventually we're going to see it. That didn't happen, okay? So this is also reinforce this idea of quantum states that says either these electrons are going to exist in very discrete energy levels, and either you're going to give them enough energy to be free of that nucleus. If you think of it as being like, instead of a gravitational well, you think of it as being like an electrical potential well. And either you're going to give it enough energy to get completely out of that well, or you're not. So that photon coming in has to at least equal that work function. So I got to show up with at least $500 to get Cohen out of jail. Now, if I show up with $550, so I show up with $550. That's going to be, I'm going to have $50 left over. So I'm going to show up with $550 to free Cohen. I got to give the judge $500. What do we have left over?
50.
That's how much we can use to create kinetic energy. Okay? It's like, wow, hey, let's go grab McDonald's, ribs, whatever. Okay? We're out. So if you want to think of this as another way in terms of stopping potential. So again, if you look at what you can measure, you cannot see these individual photons. You cannot see the individual electrons. But what you can measure is current. So that K max, that maximum amount of energy, how you actually measure that is you set up the voltage to stop that current. So what would happen is that you would shine light on here to create a current. Okay, everything's going to be neutral. You're going to see a measured current going around in this loop. We're freeing Cohen's, God forbid, by the millions. Okay? Right? And we're going to measure Cohen's per second. But people are going to go, this is too much. We got to stop some of these Cohens. Okay? So, if these are negatively charged particles, which they are, if we want to stop them, Do we want to make the plate that they're going towards negatively charged or positively charged? Negatively charged, okay? And we're going to make this side, if that's going to be negatively charged, the other side by default has to be positively charged. So what will happen is that I can fine tune, and this is the whole practical side of this in terms of how it works. I can fine tune and turn a knob and then finally adjust the voltage across that gap. And let's say, for example, I figure out that that takes 1 volt of energy, or 1 volt of potential across there to make that stop. Now, conveniently, we're also stopping electrons. So, in terms of K max, if it takes me 1 volt of energy, that's going to be also, wait for it, 1 electron volt, because that's how much energy it would stop to take an electron. So if you can figure out how much energy that it takes to stop it, like 1 electron volt. So if you know this number, and you know the information on the light, then you can solve for the work function. Because it isn't like, oh, here's a piece of calcium metal. Cool. On the back side of it, here's the information. Oh, here's the work function. It has a certain number of electron volts. So what you'll see is that in these situations, almost all the times your energy is going to be in electron volts, because of the fact that that's what your stopping potential is going to be in, is in electron volts. Okay, so that's the broad idea. So we're going to kind of finish up the theory tomorrow, and then we'll actually start like a 2-day lab on the photoelectric effect, which we will start on Friday. Okay. Oh, what do we got? Got that. All that's done. All right. Yeah.
No, ask your new seat partner.
Please?
No, it's too late.
Cohen has some.
Paper?
Oh.
I need paper.
Oh.
So this is out of chapter 28.
No. Go ahead. Yeah, I know.
You left me.
No.
I should get 2 pieces of paper
You
for
didn't
compensation.
even try something.
Yeah.
Yeah, you only do shit. Once you wanted something.
Yeah, but
I'm just trying to use it.
you're using.
I'm not using it.
You know what?
Yes, you are.
I'm done with you.
Fine. I'll write my assignment on my desk today.
That'll really help you when you get home.
I'll bring the desk.
Taking the desk.
No balls.
Oh.
Yep.
Is that it?
Dude, he doesn't believe in you.
You gotta prove them wrong.
I'll give you one piece of paper in college
Hold for a second.
as interest.
Oh yeah, what did I do?
As interest. For this transaction.
How was that?
Don't ask questions.
Without paying the principal?
We don't need principles. We just.
I'm pretty sure the interest would be higher than 1 piece. I'm pretty sure it'd be like 2 pieces.
Of course it is. Because
Okay.
Yeah, the book is.
So if you're one of those that looks in the back of the book to see if your answer is right, the answer to number 9 in the back of the book is wrong. Okay, I'm going to tell you this straight up. Okay, I have no idea where they got their answer, but it's completely wrong.
So then
Okay.
what should it be?
I'm just, I don't know.
Can you toss it?
But all I can tell
Any
you
number
is that
but
the
that one.
answer to the back of the book is wrong. Okay, it's a pretty straightforward calculation.
I have to do
I'll
this.
tell you this, Charles. The answer to number 9 in electron volts would make a GPA.
Like,
3.21. That's my plan.
How would you find
A little bit better than that.
2.4.
2.4 is better than 3.2.
Charles.
Wait, I'm gonna guess him say 1.3.
what?
What?
Charles, that's 0.2 GPA.
I heard
Right
1.
there.
It is 3.4
2.3 GPA at 2
1. It's between those two.
2 point, no, Charles, 0.23.
No, 0.03.
God, you have that.
Okay,
Come scratch my back.
Somebody's
anyway.
dying.
What?
Where did I come from?
Whoa!
So Bird got big attacked. Save me, Bird.
Oh, Cohen, I'm gonna get you out
He's gonna
of
let
jail.
it, he's gonna let it
That's what it's
happen.
about. All right, Danny.
Hey, yeah, what was it?